Welcome. Today we've got the USGS NG Talk delivery team. It's going to be providing us with an overview on a new image delivery platform that takes advantage of the Meta Raster format, MRF. And this is a spatial data service that we've got running over at the National Geospatial Technical Operations Center in support of the National Geospatial Program. Go to the next slide. Just give an overview of who's presenting. So we've got Liz Huselid, who is a project manager. She manages the delivery development team. And then we have Kwin Keuter, who is our lead developer on that same team. And this group has really been working to provide some really enhanced functionality, specifically the imagery service that is now running. It does have a public endpoint, and we're really excited for you to get an overview of it. And perhaps some of you might actually be able to use some of the services that we are exposing and making available. Next slide. So a couple links. I think we'll distribute the PowerPoint itself so that you can click on these links, but really the ones to be aware of are the National Map Advanced Viewer that kind of gives you that web-based interface for the National Map visual services, and then the National Map Downloader version 2, where you can download all of the public data that we make available. And then finally, the API endpoints, where if you want to construct your own application, you can kind of hit our services and make use of a variety of imagery, elevation, data and information APIs that we hope that you'll use and consume to make new products. With that, next slide, we'll get going with our feature presentation. So I believe Liz is going to start us off, and then we'll go in with Kwin. Welcome.
Hey, thanks everyone for attending. As Derek mentioned, my name's Liz Huselid, and I'll be starting us off today with a quick intro. I wanted to shout out to Kwin Keuter and also Kevin Corzine, our two of our lead developers and delivery team that did a lot of this work. So next slide, please. So just a really, really basic overview. What are we talking about today? So we have a nationwide NAPE imagery web service. It's a map server. And just in case anyone didn't know, what this audience is going to be like, Orthoimagery is geo-rectified images of the Earth's surface. And this service allows viewing and mapping without downloading the imagery, which can really help people who just want to do light GIS work. NAPE stands for the National Agriculture Imagery Program, and it's state-by-state imagery acquisition. And the important thing about this that makes it different from Google Maps or any other image service out there is that it's public domain. It's also updated on a yearly basis. Different states get added each year, and it's mostly run by USDA and the FSA, and there's some information there. And next slide, please. All right, so our previous iteration was a national scale mosaic, and it was stored on on-premise hardware. So that's a huge nation's worth of imagery data. You can imagine that's quite massive. The size of NAPE imagery data keeps increasing, and it's actually beginning to outpace our on-premise caching and serving ability. So we needed to kind of look at new solutions for this. And we always find it's been really useful to move things to cloud. So the National Map already offers an elevation MRF web service that's DEMs, it's elevation data. I believe we presented on this at a previous CDI meeting. And we apply the architecture and lessons learned from that to handle this orthoimagery. So it's important to note that DEMs are one band rasters. They're a single band. It's just one elevation that's shades of gray to the human eye. But imagery is 4 band rasters. There's a red, green, blue, and infrared. So that's 4 times the data in a DEM. Next slide. So how are we going to accomplish this? We decided to go with meta raster format. So that's an image format that breaks the data into 2 components. First, you have a pointer file, which is small and light. So we put that in some fast, expensive storage close to the servers that's going to be serving it. In our case, we use EFS on AWS, and we'll go into more detail on that later. And the second part is a compressed image file. So the imagery itself. We can store that in cheaper normal storage and just use the pointer to point to it. So our service shows overviews when it's zoomed really far out, so small scale. So that's like a traditional Mosaic, like our old other service. And it shows the MRFs, the image files themselves, when it's zoomed all the way in to large scale. And one nice thing about this is we can configure it to improve performance. Next slide. The result of this work has been a cloud optimized nation scale imagery web service. And we can really take advantage of the decoupled nature of cloud services. And it gives us fine control over those cost performance trade-offs you have in cloud. So we can change the storage type and the price varies based on that. You can change your compute instance or server type and speed. Again, like there's all these sliders you can move in cloud, right? And we can also change where we serve overviews and where we serve the full resolution image data, the MRFs. It also allows change-driven updates to imagery. NAPE produces new states worth of imagery every year. So with this format, as opposed to a traditional Mosaic, we can go ahead and slide in that new imagery as soon as we receive it. Next slide. So this is a screenshot of the Orthoimagery MRF service. It's currently in beta. So it's out there running, but we're not quite ready for full public release yet. There's still some things we'd like to configure with the speed to make it a little bit faster. All right, next slide. And one great thing about this is since it is still contains all of the bands. We haven't, removed any of the data. You can still do imagery analysis. You can remix your bands however you want, and you can get that data to do analysis and export. So you can do natural color, CIR, and DVI. And with the next slide, I believe I will hand it off to Kwin.
Thanks, Liz. As Liz said, my name is Kwin Keuter, and I'm a lead developer with the delivery team here at NGTalk. I'm going to go into a little more detail about the process of building the service and everything that is involved in that. So just a quick overview from the developer side, how this is built. Our first phase is serverless, and we'll talk about what that means. We have to first acquire the source imagery, and I'll talk about how we do that in a moment. Those source images are in a different format from what we ultimately want to use, so we have to translate them to MRF using GDAL. We extract some metadata, and then the second half is where we actually put all that data together and publish it as a service. And right now we do all that in the cloud, but we rely on EC2 instances. So a quick note about acquiring the source imagery. We did a poster on our Elevation MRF service, which uses pretty much the same concepts as we'll talk about here. And someone left an interesting anonymous question on our poster last spring, asking what happens to all the source images once we finished converting them to MRF. And I thought that was an interesting question. And so, perhaps they were getting at the fact that these are essentially copies that we're making, which means that they're stored in one place, with the owners of that source imagery, and then they're also stored in our system. So why would we make copies instead of just using the originals? So one reason is that ease of access. We don't actually have the level of fast access that we would need in order to use those source images in our service here. Also, that gets to the point about autonomy, where the owners of that data, they might decide to organize differently or make changes that would affect our process. And so, we try to be decoupled from that, and making copies allows us to do that. And we also want to change the file format. So the source images are uncompressed geotiffs, and they can be quite large. The average ones might be around 500 megabytes. And in order to make the service run well, we want to try to reduce that. And that also saves us cloud storage costs by compressing those images down. And ultimately, compression gives us faster performance. So the service has less data to turn around to the user when we apply compression. And I think that for anyone who's familiar with the notion of one ring to rule them all from Lord of the Rings, I think that was kind of a tenuous proposition in the world of Middle Earth, and it's definitely a tricky thing to do here on actual Earth. And this is actually something that we are sort of approaching, trying to avoid duplication where we can, especially across agencies. But even then, there'll still be a necessity to make copies so that you can use the data for different purposes effectively. So the format that we're converting these source images to, as Liz mentioned, is the meta raster format. This is a cloud optimized format designed by NASA for tiled imagery services. It's similar to cloud optimized geotiffs in that internally you can have multi-resolution tiling, or what are called pyramids, but MRFs are a little bit different. One difference is that MRFs give you the ability to make clones, which were alluded to before, and these are lightweight pointers. They're actually XML, and they're only about a kilobyte, and they point to the full image, and that separation allows you to optimize your cloud storage so that the really small files that you want fast access to, you can put those in faster, more expensive storage, and the really big images, those can be stored in cheaper cloud storage. MRFs also come with built-in caching support, which I think is fairly unique. So they can generate their own cache files. So once you've downloaded it from your slower but less expensive cloud storage, you can hold on to that cache file, for as long as you need to, so that you don't have to go retrieve it again. And lastly, MRFs allow us to choose our own compression format. And in our case, we use something called LERC, which I'll talk about in a minute. So I mentioned the value in kind of optimizing the different cloud storage options to make the service run effectively and as cheaply as possible. And in our case, we're using 3 different cloud storage options. One, we've got Amazon S3, which is the kind of cheapest option. It's extremely scalable. So multiple clients could be downloading files from the same S3 files simultaneously. And the service has no problem with that. But these are also a little bit slower than the alternatives. We use Elastic File System, or EFS, for some other things, and this is more expensive than S3, but it's also extremely scalable, and it's not quite as fast as EBS. And I apologize, this is a very gross oversimplification of cloud storage. I'm sure there could be cloud architects on this call who would be protesting, but Elastic Block Store, or EBS, this is for attaching to individual EC2 instances, kind of like a solid state hard drive. And again, these are more expensive than S3, but they're extremely fast, but they don't scale. They're just kind of a one-to-one relationship between your actual machines. So we allocate our different pieces of our data in this fashion. So we put the full MRFs, which are the actual images in S3. Those clones, which are pointers, we put those on EFS because we're going to have multiple instances that need to access them. And EFS makes that really easy. And then those cache files that I mentioned, which are basically the same thing as the full MRFs, we put those on our EBS volumes. But they're temporary, so you're not storing the entire data set. You might only have 1% of that in any given time in EBS. So the compression that we use, I think, is kind of one of the more subtle but interesting points. So LERC stands for limited error raster compression. And the idea here is that you can choose the maximum compression error per pixel when you perform the encoding or compression step. So if you wanted lossless compression, so the pixels are exactly the same as the source, you could do that. If you were okay with introducing some error into the compression, you would see even more size savings as a result. And that's shown in this table on the left here. Just one example, the source image was about half a gigabyte. And pretty quickly we can cut that in half with a very limited amount of pixel loss or variance rather. So on the right, you can see what this kind of looks like at a very basic level. I think for the average human eye, or at least for my eye, which maybe is not average, might be less than average, it's pretty hard to tell the difference in a few pixel values here and there. As you can see on the top half of the chart, it really starts to take a difference of, I think, about 12 or 16. You can just barely detect it. So the amount of quote unquote error that we're introducing here is not, at least for visualization purposes, is going to go undetected by most users. And here's an example of what that looks like. This is the same image zoomed in really far, a scale of 1 to 300. And the top left is the uncompressed geotiff. So that's our source image. The top right is LERC compression, but lossless. So in theory, these should be exactly the same image down to the pixel. And then the bottom two images are an error threshold of 2 and 4. So it really, I think you can kind of see a difference in the water, on the bottom right image. But for the most part, it's extremely hard to tell. And again, this is zoomed in really far. So it's going to be hard to notice, but you might notice the speed difference since these are much smaller. So the general idea that we try to apply to our architecture in processing all of these native images is what's known as serverless. And this is a cloud native development model. And the main idea here is that machine resources are not something that you worry about. So that's abstracted away from you. So, where the physical hardware lives, you have no idea. You have no idea how many different actual physical machines might be running your code. It can be highly distributed, and you only pay for what you use. So, and this is even a difference, compared to EC2 instances, which can often sit idle. So you also don't have to worry about patching those instances or building or configuring them. You just basically run your code and pay, usually per millisecond or per megabyte of memory that you've allocated. And so this is rapidly scalable. So if you had a process like ours where you wanted to process a lot of images quickly, there's really no barriers to doing that. And kind of the crux of our serverless process is AWS Lambda, which is Amazon's function as a service offering. And here, basically, you just upload, a relatively small amount of code, and you can execute that code concurrently. And we'll see in a moment how that kind of fits into our architecture. So the imagery acquisition process has a few steps before we can actually process the image. And most of the boxes in this diagram are Lambda functions. And we're using what's called AWS step functions to orchestrate all of those Lambda functions that are doing small, tasks that, kind of assembled together give us our processing workflow. And step functions are a really great resource for, again, for serverless task orchestration. You can pass information between states. So the output of one function execution can go to the next function, and it can make a decision about, what do I need to do next? And you can also schedule these workflows where you could define certain events that would trigger them, or you could just run them manually. So just kind of at a high level, one part of this is acquiring the imagery. We're using our partner's API to search for images based on the year and the state code. And we generate download links that then we, kind of push through the system. And as we download each of those source images, we process them. And so this green box, it kind of sits over top of the actual MRF pipeline, which I'll show in a second. But at the end of all this, we have to output our metadata about each image. So we're kind of waiting to see, did we finish processing all of them? And once we are done, then we can safely export that metadata. The MRF processing is really a kind of buffet of different serverless tools. So I'm not even sure that explaining the diagram on the right will be really that effective, but just a brief bit about what we're using here. Again, AWS Lambda is the biggest part of this. We actually bring the GDAL library into our Python functions using Lambda layers. And then we use the simple queue service to kind of stage messages about, each message would say, this image is going to be processed next. Here's where it lives in S3. Here's how big it is. Part of our workflow relies on determining how big is the image, because if it's really, really big, we have a little bit different way of processing it. And so we just need to know how big is it. We keep track of some of our metadata with the DynamoDB, NoSQL, Amazon offering. Again, we're using Elastic File Systems, S3, and some monitoring tools that are built into AWS so we can see what's happening. And just in general, this approach has a lot of benefits for us in that we can scale up or down as needed. So in AWS, an account has up to 1,000 concurrent Lambda executions available. So at any one time, you could be doing a function 1,000 times at exactly the same moment. And we don't quite need all of that, but when it's when it's off-peak times and our teammates are not using that Lambda concurrency, we have some leeway to say, let's use a little bit more.
Hey, Kwin.
Yeah.
So, looking at this architecture, I was just wondering, did you originally conceive of this as a serverless architecture, or did you kind of start from and we're going to do this with an EC2 EBS and then move that forward? I just wanted to kind of get an idea of how this was conceived and started, and then where you ended up.
Yeah. So where this ultimately started is with a project, a collaboration between some NGTalk staff and Esri on basically an EC2 based kind of assembly line version of this, where you were just doing one job at a time, and it had to be on an actual server. And so that kind of set the stage for some of the core elements of this, such as using GDAL to convert from one image type to another. But my predecessors, they envisioned how this could be moved into the cloud. And even part of that process used something called AWS Batch, which is technically serverless, but yeah, it's just been an evolution, and just I think the what's driving this move to serverless is that ultimately we want kind of continuously self-updating imagery so that we can automatically respond to events. The state of Iowa has new imagery, just let's say hypothetically, we could respond to that event, automatically start processing it, update the service, and just watch all this happening instead of manually running those kind of tedious processes ourselves.
Thanks, Kwin. Hey, there is a question. Liz, did you answer that one on cost? Just wanted to see if I know we've got Robert and Rob. There's kind of a question on how much.
Yeah,
how much,
Robert. Right. Sorry, I tried to answer, but Robert or Rob might have more info. The question is, what kinds of costs are you seeing annually with the only pay for what you use model?
Well, to Rob, I can say one thing. At least when we started this project, we've been migrating our services to the cloud over several years. But when we looked at just setting up image server in the cloud natively without any change in our architecture, how it was going to be way too expensive for us to maintain the monthly cost of running it, as straight as a database. I get what am I using my right term, EFS, or not EFS, but anyways, a database serving system. So we knew we had to re-architect. So we don't have exact cost comparisons from this architecture to what might have been the other, but we do know from setting up our elevation service, very similar to this, it's not nearly as large a data set. We've been able to manage the cost, I'd say, pretty successfully. It stayed within what our plans were. Something like the elevation service, it's a national service, fully open to the public. I don't have the number of hits offhand, but something like that might run us, it's been, run us in the 20,000 a year type of range, but that's a full national service, fully open to the public. So obviously this is more storage and may have other costs to it, but we'll be looking at that cost more, certainly keeping track of it as we go. So, Kwin, do you have something else you want to say on it?
If I may chime in really quick, I think I am unmuted.
Yeah, thanks, Rob.
Oh yeah. So basically there are two pieces of puzzle here. One of them is obviously the processing pipeline, and we definitely are seeing the cost reduction there. And it's a little bit of kind of tongue-in-cheek answer there, because Lambda functions have a kind of that free tier that we're kind of using every month. So therefore, there is definitely a cost that is hidden, or actually it's free. So we're kind of tapping into that potential. But from the perspective of actually processing cache and serving cache, we have two different types of cost. I would say that serving, not cache, my bad, serving the MRF tiles is probably more of that old school, having EC2 instances, serving stuff and doing things and whatnot. Much bigger footprint and obviously more cost as well associated. Whereas, just like Kwin said, we've migrated from occasionally turn on, press a button and process what you have in the queue to we migrated to more reactive pipeline where we want to kind of process when things come in. And of course, with serverless technologies, I did mention in a response to Derek there that this was originally a proof of concept piloted by Esri that was not really built for scale. It was just a proof of concept. And then folks like Kwin and Kevin Corzine, they actually took this to the next level, which was okay. Let's split this out. Let's make it scalable. Let's use the cloud native technologies rather than brute forcing the problem.
Sorry for that interruption, Kwin.
I think that adds a lot, and
Okay.
I think that really I was going to wait until the end, but wanted to give a shout out to Robert Jurashai and Rob Dawson, who've been absolutely crucial to this effort. On a technical level, I've benefited greatly from collaborating with Robert Jurashai. So this isn't just me operating in a vacuum. So thank you for adding. This kind of concludes the processing part of this, but the MRF processing pipeline is really where I spend most of my time. The next part, we're going to talk about things related to the service. And that's, I got to give all the credit to Kevin Corzine in making that work. So now we're in kind of the EC2 based part of the process. We've got all of our data converted to MRF. It's being stored in S3 for as cheap as it can possibly be. And now we're going to get ready to stitch all of that imagery together and make it publicly accessible through ArcGIS image server. So one key concept here is the idea of a Mosaic dataset, which is an Esri data structure. It's basically like a table that contains all of your image tiles, whether they're MRFs or overviews, which we'll talk about next. And it basically just defines all the different scales at which those MRFs or overviews will be displayed. And it also is the basis for creating overviews. And in this diagram, this is just one small part of the New England part of our service. All these little green lines, those represent individual MRFs. And then the blue lines, which might be hard to see, those are the different overviews we have. And you can also kind of see that we haven't really talked about this much, but this is all segmented out state by state, so that when a new state gets, when a state gets new imagery, we can swap out the old imagery for the new without having to rebuild the entire 48 states. So overviews are, they're basically downsampled, copies of the in our case MRF imagery, so that and it's kind of like a layered cake, if you will. So at the bottom, you've got all your source images, and we have a process that progressively stitches a few of those together that are adjacent and creates a new image that's been downsampled. So the pixel resolution is lower, and that makes a smaller image that is easier to render when you're zoomed out. And those overviews kind of build up on top of each other based on a scaling factor that you can choose. This is just kind of a generic diagram from Esri. And this allows us, when you're zoomed out at the, national scale, we don't have to render over 200,000 images, which are roughly how many images are in this data set. Instead, we can just render a handful of overviews, and that works really fast. So once we've got our Mosaic data set created and we've built our overviews, now we can actually publish the service. And this is probably its own presentation or two, but I'm just going to quickly highlight how this service is a little bit different. We're using the concept of load balancing. So these are EC2 instances, but they auto scale, or the concept is auto scaling. I might have misspoken there. And the idea is that, when we have peak demand, we can scale up the number of instances that are helping run the service accordingly. But then, overnight, when we're not really getting any traffic, we scale all the way back down to one instance or zero if we feel like it. And these instances are running on Linux, which makes them a lot easier to kind of treat as ephemeral and configure, automatically. But it is running ArcGIS image server. And again, this is where our different storage concepts come into play, which I talked about earlier. So, our hope is that when we're ready for an official launch that we advertise to the world, that this auto scaling will be optimized. But we've got all the pieces here working today. So there's, this is always a work in progress. So you probably saw in one of the early slides, we had a screenshot of the whole service. There were some gaps in there. Some of those are redacted areas, but others are gaps where, our partner that's providing the source imagery, for whatever reason, one of those tiles was missing here or there. Our coverage rate is, pretty close to 100%, but we want to get all the way there. So we're going to work on some tools that help us kind of intelligently detect where we need to go fetch maybe the image from the prior year, if it wasn't available in the current year. We're trying to push towards a kind of continuously self-updating data set. So again, that we can just focus on making this better rather than going through the toil of manual steps. And part of that involves automating Mosaic dataset and overview creation, which we might do one day, we'll see. We're also trying to work on the speed of the service. That involves just some optimizations to our EBS volumes, most likely. And I mentioned we want to have our auto scaling working optimally. And lastly, this is, some of you might be familiar with the idea of tiled or tile caches, where you've kind of statically prepared all of the individual tiles ahead of time, but you've given up some of the dynamic abilities, such as on-the-fly raster functions. So those are always trade-offs that are worth revisiting. But I think that's where we get to the questions portion of our presentation.
Thank you, Kwin. That was a really good explanation of a pretty complicated topic, and I really appreciated your the overview. Great images. We do have Megan has made Rob Dollison and Robert Jershai co-hosts as well. I did want to kind of provide an opportunity for Rob to mention, he is our National Geospatial Program delivery theme lead. He oversees a lot of this effort and kind of has a vision for where these services are headed. Kind of wanted to see, Rob, if you wanted to provide kind of an overview, not just with the NGP service, but also some future services that might be coming up that you're involved with.
Yeah, thanks, Derek. Well, this has been, certainly a lot of work that Kwin and Kevin Corzine and Liz have all been very involved with for the last several months, and it's exciting to see the progress. We're really looking forward to getting this imagery service out there. So just a little bit, certainly imagery and primarily the NAIP for most of the continental US has been the foundational data set in our US topo production process and part of our key product. We've also had that sort of being co-leads with imagery with the US Department of Agriculture, had a role in imagery, and certainly Department of Agriculture now with the NAIP program is the really provides the core base of larger scale imagery for the nation. So we've moved most of our services into the cloud. We've wanted the reliability and the scalability, and we've seen a lot of great enhancements in that over the years. And this is pretty much our last big effort to get what has been an on-prem service into a cloud environment. And so I think where the NAIP has been a great success story in the collaboration of many agencies acquiring the data, all pitching in and being able to get national coverage at more and more frequencies of updates. One of the big areas for improvement is still sort of the managing and sharing of that data. We have a lot of agencies that all wrestle with making copies of this data set and hosting it and sharing it. That's a lot of work. And so we're doing some neat work with the Forest Service right now, collaborating on an imagery hosting platform, shared platform that ideally we could be doing this type of work more in a collaborative environment without having to duplicate some of the efforts we're all putting in. So I think in the future, that's where we're trying to go, is to take a lot of the work we're doing in this service right now, but then eventually migrating that out even to a more shared environment where, besides the full US national service that we provide now, other types of imagery capabilities, whether it's historical NAIP, other things would be available in a more cross-agency environment. So that's just a little bit of sort of where we're going next on the imagery. But we're really looking forward to this, this one getting in place, and a lot of the lessons that we've learned from Kwin's work being able to move us into that next phase. So thanks.
Thank you, Rob.
Thank you.
All right. I think Kwin's already answering questions that are in there. Megan, did you want to kind of bring people off of mute? And then if you are seeing any direct messages, that'd be great. I'm just looking through the chat right now.
So Derek, yes, I did. Everyone has the ability to unmute now, right. So feel free to go ahead and ask questions that way, or you can raise your hands, or the chat's still a viable way. I was scrolling backwards, just trying to see, and I might be mistaken if this may have already been addressed, but there was a question about, I believe it was AWS costs annually would be only pay for what you use. I'm not sure if that was covered yet or not, but I see that as the first question that was asked.
Yeah, did we answer that completely? Were you asking for an actual, like our monthly cost for the service? I was just kind of getting, I don't.
Yeah, that question came from Toby. I don't know if there's any additional context for that.
Toby, if you're still on, did you want to just kind of ask directly? Or Toby might have dropped.
Yeah, I'm not sure I see Toby in the participant list.
Robert, did you have kind of a back of the napkin, kind of a monthly cost? I know you helped to aggregate the center cost for cloud. Have you broken it down to the service level?
So again, just like I said, there are two pieces of puzzle here, right? One is the cost for updating or running the processing pipeline, and that's the cost that drove down. Well, there's going down because it's only what we use. There's still kind of this fixed cost of serving these services.
Do you have kind of a ballpark? I think he is asking for a number. Do you have kind of the thousands, hundreds, tens
I would
of thousands?
say just serving the service is probably, a couple of thousands, depending on whether it's on Linux or Windows. So that's for serving. But as far as
a couple thousand per year, a couple thousand per month,
a couple thousand per month.
A couple thousand per month. Okay.
But processing is literally in maybe less than $100 a month.
Okay. And then that compares to when you would, if you were to do this using an EC2 model.
Yeah, when we used to use EC2 model, it was definitely in hundreds, maybe thousands. And of course, I don't want to go into details, but the way we are processing changed. In the past, used to be process everything over and over again, and possibly nowadays we can do more atomic processing pipeline. We just process what changed, not everything.
Okay.
Yeah,
Thanks.
Derek, I would say obviously, the cost per month to run the service is going to depend on your user base.
That's right.
Right? How much egress you're doing. This is a full national public service. Anybody can hit pretty wide audience base. And so cost would be certainly higher than if you were running a much smaller area or more focused application. But yeah, I would say, 2,000 a month would be a starting point anyway for what we'll probably be paying, I would think, to run the service.
Okay. And if anyone wants to run a national imagery service, please do and let us know so that we can shut ours down. Okay.
Yeah, and Derek, I'll just add on the processing side, where I'm most familiar. I think we had kind of fixed costs for processing MRFs. I think Robert showed me they were around $100 a month, and then we moved to more event-based processing, so we weren't incurring those costs every month. And I think that particular data set maybe costs $5 to process about 50,000 images. But now we've actually moved beyond that to where now we're only processing what's new. So we no longer have to process, in the case of NAPE, all 200,000 images. We're just going to process whatever is new. So it's kind of hard to keep track of exactly how the numbers are coming down, but it's pretty dramatic.
Yep. Carl, you chimed in with something there. You want me to read that, or do you want to speak up?
Am I unmuted?
You're good. I can hear you.
Hey, cool. Yeah, I just wanted to plug that, focusing on hosting cost is good, but it's just one part of the total cost of ownership picture. And depending on your organization, you might have, excess staff time. You might have not a lot of hosting costs, and picking what you optimize for is something that can vary a lot from group to group. Coming from a spot where we are often limited in staff time, but not in terms of hosting costs, we tended to shift more to the serverless solutions because it frees up staff time by delegating a lot of the operational work to the cloud provider. But obviously your mileage may vary depending on the context you're operating in.
Carl says he means USGS water mission area.
Yeah, sorry.
What mean we? Okay.
Yeah.
Megan, any other questions out there? Oh, go ahead. Sorry.
Hey, Derek, this is Robert really quick. So I checked the cloud checker, at least for the current cost for our imagery servers, servers is around let me just see, $500 a month. And that's
you're fired, Robert. That's it. That's way too much.
Both development and production. Now,
now.
again, just like Rob said, this is still not released publicly. This, obviously as it scales, we'll know the actual, true cost. But also to resonate what Kwin said, that our processing cost went down to dollars.
Yeah. That's a great story. Thanks. Any other questions?
I do not see any additional questions in the chat. I do see a comment from Carl about serverless solutions.
Yeah, that's great. We know him. He's a rabble rouser. All right. I think that's it. I mean, Liz. Oh, Carl, you got your hand up.
I had one more question. If I guess I'm a rabble rouser. I'm curious, and maybe this is all old news to this crowd, but I'm curious what some of the trade-offs are with the MRF format versus some of the other formats out there. I've heard quite a buzz about ZAR, which is kind of a cloud-optimized HDF5 based file format. I was curious how folks would decide to use MRF versus ZAR versus some of these other cloud optimized largely raster formats.
So Carl, before we jumped into that really quick, Derek, I want to correct myself. I fat fingered I selected 2 months, so it's actually half that. So it's $250 for a month.
Oh, okay.
My bad.
You're forgiven. All right, Kwin, you want to answer that question?
Well, I thought, Carl, you would ask about cloud optimized geotiffs. I have heard of ZAR, but I wasn't sure if it was actually intended for use with rasters. But just real quick, I'll just talk about cloud optimized geotiffs for a second. So the understanding with COGS is that because you rely on byte range requests, they have the internal tiling that would allow you to do something like pyramids or overviews, but COGS kind of shift the responsibility for figuring out how to make those byte range requests to the client. And we wanted to provide a robust service that just allowed people to load this into a map or their desktop client and just start using it right away. So, and again, I think the caching and pointer functionality of MRF is certainly something we've been able to take advantage of with a lot of success. But I'm always curious about other formats out there.
Okay. One more question out in the chat, and then I think we'll kind of call it. So we got that question from Jamie. Jamie, if you've got a mic, you can just ask directly, but I'll read it. Is the CONUS NAPE image service live yet? If so, how many hits per day, week, month does it receive?
Yeah, it's actually a public endpoint, but it's not really getting much traffic because we haven't advertised it yet. We're hoping to make some of our optimizations before we start. It's going to be a mad dash. When people hear about this, Twitter is going to explode. So we want to get ready, but we don't have those numbers yet. Yeah. Okay.
What did somebody was about to say something? I thought I heard someone's voice kind of jump in.
Oh yeah, sorry, that was Liz. Hey.
Hey, Liz.
So we do have our older traditional Mosaic NAPE service. So we could run metrics on that. That's what we're using at the moment. But this new MRF one is not fully publicly advertised yet.
All right. We are kind of closing in on the top of the hour. I think we kind of paced ourselves very well. Again, Liz, Rob, Robert, Kwin, thanks so much. Really provided a lot of great information and obviously attracted a good number of people. Thanks for staying on for the event, and we look forward to seeing you next month.